In this video, I'll be working through the maths question you see on the screen here from 2024 Cambridge A-level mechanics paper. If you're looking for a different question from this paper or a different paper entirely, check out the description below for a link to playlists. And if you find this video or any of my videos useful and would like to help the channel out, if you are in a class group with other people sitting the exam, a share in that group would really help out. Failing that, a like, subscribe, or even a super thanks. As with a lot of mechanics questions, their first job, and indeed sometimes the hardest job, is to understand what the question is saying, because it can be a lot of English, a lot of explanation. So I'm going to spend a few minutes explaining this without maths. I'm going to draw a few pictures and I'm going to go through the whole question pretty much without maths, just so you can understand what's going on. I especially feel bad or feel sorry for people who English isn't their first language, because often there's a lot of English in these questions. So what are they saying here? They are saying that there's three objects, A, B and C, and they're like on this straight line here, and we'll call the objects A, B and C, and we're calling the position they're in X, so that's X, Y and Z. They tell us the weight of these guys. This guy is 5 kilos, is it 1 and 2 here, and they also tell us some speeds. This guy's going at, let's see, speed of, is a 6, the starting guy. Let's see, I have it here drawn here. So yeah, this guy's going at a speed of 6, he's not moving, and this one is going to the left at some unknown speed. But that causes confusion later, by the way. They give a V and they tell you it's going left, so that means it's a minus, but V is a positive, but we're going to use it as a minus because it's going in the minus direction. I think they could have avoided that, but anyway. Now they tell a story, and the story's interesting. It makes a great question. When A is moving to the right and B is staying still, so they're going to hit each other. When they hit each other, they use an English word that I don't blame some non-English people for not knowing, or even if you speak English perfectly, you might not know. Do they say coalesce? Yeah, coalesce. That means to come together, to join as one. So A and B are going to mash together and come as one. So let's draw this all again. We'll have X, Y and Z. X, Y and Z. A and B are going to hit each other and turn into one object. The 5 kilograms and the 1 kilogram will become 6 kilograms. C was traveling, it's going to be somewhere, I don't know where, somewhere here, and he's still going to be traveling at V speed, and he's still going to have 2 kilos of weight. After they hit, this guy's going to stay moving to the right. Do we know that? Do they tell us that? No, they don't quite tell us it moves to the right, but we are going to figure that out on our own later. Did I put this 6 in? Sorry, this is moving. Oh, sorry, that's 6 kilos, isn't it? Let's put kilograms in there. 6 kilograms, and it's moving at some speed. We'll call it VD for now. We can find this. This is going to be one of the questions we do quite early on. We're going to be able to find this speed. These two are heading towards each other. They then tell us they hit. We still have X, Y and Z to see where we are in the world. They're going to hit somewhere between these 2 points. They're going to combine together to like 8 kilos of an object. And they still tell us it's going to move to the right at some speed. Okay, so that's the situation we have. They're going to just ask us some questions about this world. I'll leave this picture up, so I'll limit myself to this space over here. I should have been a bit neater. Okay, the first question they ask you is, show that the collision of E. Sorry, I should name some of these. This was A, B, C. This is C again. This guy turns into a D. A and B combine to a D. And D and C combine to an E. Okay. They ask for the speed of E. This last speed here. What is it? They give you the answer just in case you can't do it yourself. But what is the speed of this in terms of this speed here? So let's just go about doing that. hopefully what jumps out with you when two objects hit, you know their mass, you know their speeds. You should be thinking momentum and conservation of momentum. So let's do the first part of the world. The total momentum in this world, we'll forget C for the moment. We're just interested in A and B. They're going to hit. Before they hit and after they hit, what's going on? The momentum of A is its mass 5 times its speed 6. The momentum of B, we'll add them together. We'll want the whole world of A and B. The momentum of B is its mass 1 kilo multiplied by its speed 0. Total number there is 30. 30 plus 0, 30. After the collision, what is their after the collision, what is their mass? Their mass is 5 plus 1, 6 kilos, multiplied by some number, we'll call it VD. Yeah, I put in VD there. And this has to equal the same thing, conservation of momentum. It doesn't change before or after, unless there's some losses in the system somewhere where they haven't told us there is. So what's VD? VD is just equal 30 over 6, which is equal 5. So we now know the speed here. Let's put that in as 5. Okay, we're still interested in this guy down here. So we'll go before and after the next collision. Before this collision, what happens? The momentum of D is, he's 6 kilos now, multiplied by 5 speed. That's added to the momentum of C. C is 2 kilos, and he's going at a speed of minus V. Momentum is directional. We need to know what direction it is. If it was positive, they'd add together going that way. It's not. They're going to stop each other. They're going to slow each other down at least. What's the total number of this? It's equal to, let's see, 30 minus 2V. Okay, after the collision, what happens? After the collision, it's 8 kilos and it's going at a speed of V, we'll call it VE. And that's what we're looking for. But it still equals the same number, 30 minus 2V. Yeah, they want this, so let's just equate it. EV, velocity at E is equal 30 minus 2V over 8. If they asked me to find it, that's what I would give them probably. They told us the answer though. They told us the answer was 15, not 30. Minus V, not minus 2V, over 4, not over 8. That's the same thing. 2 divides into everyone here. And we just get 15 minus V over 4. That's the answer, part A. I'm going to clear this area off. We'll keep some of the numbers. We'll need this, so we'll write that in down. Let's put it in down here now. VE is equal 15 minus V over 4. And we'll do the next question. Okay, in part B, they tell us there is a loss of energy in these collisions. They don't tell us each one, but overall there is a loss. By the way, earlier I said there was no loss, momentums were equal. It's been a while since I've done studied theoretical physics, but I assume there is a loss of mass from that energy. It's just tiny because of E equals mc squared. The mass would be tiny for that, for 63 joules. But don't quote me on that. I can't remember back in those days. Okay, so they tell us there is a loss when these hit each other. Both these collisions, the A and B and the D and C collisions, they want you to use that fact to find what V is, to find out what the value of V is. So they're talking about kinetic energy and the loss of energy here. So let's find out the energy at the start, the energy at the end, and we know 63 is missing, so we should be able to get an equation. So what is the kinetic energy at the start of the system? Let's put start here. The kinetic energy of A is a half, M is 5, in this case this is 5 kilos, times 6 squared. The kinetic energy of B, I'll write it in even though it's 0, because it's a half, 1 and 0 speed, a 0 squared speed. So that's just nothing. And the energy of C is a half, a half times 2 times V squared. Or you could write minus V in if you want. Minus V squared is still V squared. So So we're fine there. That's the energy to start the system. If I clean this up, I will get, actually let me just check my notes. 90, this all adds up, this adds up to 90 here. And this is, I guess, 2 times a half, and it's just 1. So plus v squared. That's the energy at the start of this system. The energy at the end of the system is, there's just one mass, so that's a half. M is 8 this time, and V is 15 minus V over 4, all squared. That's the energy at the end. Let's clean that up as well. I think I've multiplied this out here somewhere. Yeah, you get 4 outside, you get 4 times 4 on the bottom. Those 4's cancel, we're therefore 4 left over on the bottom. Then we get 15 minus V squared. 15 squared is 225. 15 times minus V is minus 15V. Another one minus 30V. And then plus V squared. That's the energy at the end of the system. Putting that together, I can say the energy at the start, take away any losses, which was 63, must equal the energy at the end, minus 30V plus V squared over 4. That's a quadratic. There's a V squared, a V, and loads of numbers. Multiply both sides by 4 and start equating things. We'll get 4 V squared, that 4 times that, minus this V squared, let's do it all in one go. We get 3V squared. Let's see, nobody will touch this 30, so we'll get plus 30V. And then all these numbers, this will be 90 times 4, 360, minus 63 times 4, I don't know. And then take away 225. All put together, and we get minus 117 equals 0. 3 goes into all of them. That's clear to see. 120, that's just 3, 120 minus 3. So V squared plus 10 V minus 39. Is that what I have down here? Yeah, minus 39 equals 0. That factorizes quite nicely. 3 and 13 makes 39, and 3 and 13 does get to 10 quite nicely if it's a positive 13 and a negative 3. So that'll give an answer of V is equal minus 13 or V is equal 3. That's the value of V, not its direction. Remember earlier we said its direction was going left, and V, so that means V should be a positive, and we then said it was going left. So if V is 3, it would be going that way, because we decided earlier to change it to a minus. And if V is minus 13, when we changed the sign, it would mean it was going that way, fast. So nobody would actually ever hit it. So the answer is 3. So just put a line through, minus 13. And that's what they were looking for. Okay, they're still asking questions about this situation. And let me fill in what we found out though. We found out this is a velocity of 3 going to the left. That means we know this velocity. 15 minus 3 is 12. 12 divided by 4 is 3 as well. But this guy is going 3 to the right. So the next question, they tell us that the distance between x and y is 36. Let's put it down here. 36 is that distance. The distance between y and z is 98. That's for the total distance of, add these together, we would get 134. Okay, they're going to ask us where things are basically. Find the time between these two collisions. So I want to know is when these hit each other and became D, and then I want to know when these hit each other and became E. There's a few ways you could do that. Just be careful what your time are. Keep track of your time. How I'm going to do it is I'm going to work out how much time it takes these to hit, and then I'm going to start the clock all over again, and I'm going to work out how much time it takes these to hit. And well, actually that's the only number I want, I suppose, so it's probably okay that I start the clock again, because they asked for the time between collisions. Okay, so can I skip this one? Yeah, I just realized I can skip doing the first part. I don't care about the time between these collisions, except I do want it for the next part. I'll do it just so you can see my method 3 different times. which is often helps for teaching. So I'm going to work out how long it takes these two to hit. You could do this a few ways. You could play around with your equations of motion. You have the speed, the initial speeds. You have, I guess no, the final speed's different because it's they coalesce into one object. So you have an initial speed, you have a distance, you have an acceleration being 0. So that's 3 things. You can work everything out. It's just awkward to get everything to match. It's fine on the first part because the second guy doesn't move. But whenever you're getting things to hit each other, equating each other, I don't like using the equations of motions. I like making my own. In fact, I make my own anyway. So I'm going to do that. I'll do it 3 times, so hopefully you'll be able to follow along. Before the first collision, I'm going to say A. What's the equations of A? Well, A, it has 0 acceleration. So you integrate that and you get its velocity. Its velocity is 0t, so 0, with initial velocity 6. You can skip that line if you want. So where is it? S is equal to the integral of this, which is 6t. This is not important, just I want to do this a few times so I can show you. This will tell you where this is at all times. At 0, at initial time, it's at the start of the world, it's at 0. B, again, A equals 0, V is actually 0 this time, and S is equal 0 time by time, but we know where it is. It starts off at 36. And yeah, when did these hit each other? So when are these equal each other? Well, 6t equals 36, so that should be a t. T is equal to 6. So after 6 seconds, they hit each other, and they hit each other at this point. That's there was no need to do that. You'll see me do it again now when there is a need though, and hopefully you have a bit more of an idea. Okay, after the collision, let's start the world over again. Start the clock over again. We'll start at a new time. I will use this time though later on, I suppose. Before this collision and after this collision. So at the start of this, where D is, so we put D in. His acceleration is also, all their acceleration is 0. His initial speed is 0t plus 5, so 5. His position is 5t plus, where does he start in the world? He starts at 36. And then C again, sorry, B up here, this is C, his acceleration is 0. His his initial speed is minus 3. So his position is minus 3t, the integral of that, plus where did he start? He started at 134. He doesn't start. That's another reason I need to do up here. Where is C? Let's put C in here. A is equal 0. V is minus 3. S is minus 3t plus 134. So this one's wrong. I forgot T moved along. We need to find out where he is. So where is T? Where is C after these first 6 seconds? I knew I needed to do it for some reason. So where is he? Just put 6 in here. We get a minus 3 times 6 is minus 18. Minus 18 plus 34. The position of C must be, let's see, 16, 116. So that's where he is here. This position is 116. Just see. That's how much he's moved. He's moved, what was that? 18. He's moved 18 from there. So next time we're doing his equation, we can say his speed is still minus 3, but now his position is minus 3t, and he starts off at 116. Let me just double check it is 116. Yeah, that was right. Okay, so when do these two hit? This D and this C point. Again, doing this way, it's quite easy to do then. They hit when the S's hit. So we just put these equal to each other. And move the minus 3t over, we get 8 t's. Equals 116 minus 36 is 80. So happens after 10 seconds. 10 seconds after the first collision, the second collision happens. That's the answer to that part, but I'd like to know more. Put the 10 back in here and you'll get 50 plus 36. S at 10 seconds is equal to 86. So where does this happen? It happens at the point of 86, when he's 86 along, and that'll help with the next part. That's because the last part asks you to find how much time it takes from this to E getting all the way to the end. So we need to know where E is, so that's why I found that. He's 86 along, so how long is it going to take him to get all the way to the end? He needs another 40, and that's another 48 distance. And we know he's going speed 3. So you can do a few ways. You could do the same. Actually, let me do it the long, silly way. Although he needs to go 48 distance at speed 3. That'll take 16 seconds. So that'll be part of the answer. But I'll just do it a silly way. E, equations of motions for E. It's accelerating 0. His velocity is plus 3. We knew that from earlier in the question. His position is 3t plus, where does he start in the world? At 86. So how long does it take this to become equal to the top, to all the way to Z, which is 134? So we just put this together. 3t is equal 134 minus that. 3t is equal 48. T is equal to 16. So let's put all that together. At the start of the world, it took 6 seconds for A to get to B. You don't have to do what I did. You could just have said speed 6, traveling 36 distance. It took 6 seconds. First part. Second part, when did these two hit each other? We found that out to be 10. Where is that? Found that that's another 10 seconds. 6 plus 10, we're at 16 seconds. How long does it take E get all the way to the end? Again, you don't have to use the integration I did. It's just a distance of 48 and he's going a speed 3. That's another 16. So the total answer is 6 plus 10 plus 16, 32 seconds is the final answer. That's a hard question, and I feel sometimes when you're a teacher and you're talking, you're like, I've lost them. I can't see the classroom. Usually the students are going to sleep, but I definitely probably lost you there a bit. So please ask questions in the comments. If you're not clear on something, I'll do my best to get back to you. Thanks for watching and have a great day.